Hi, this is Dan from Appland. I'm going to demonstrate how to identify the N+1 query anti-pattern using the AppMap extension for Visual Studio Code and the Spring Pet Clinic application as an example. The N+1 anti-pattern happens when a query is executed for every result of a previous query. If left unchecked, N+1 queries cause unnecessary, expensive trips to the database and the gradual slowdown in the performance of an application. Detecting N+1 queries is tricky because they are not revealed by any mainstream testing strategy. To detect the N+1 query problem, we need to look at the number of SQL queries that are performed in a realistic situation, such as an integration test, and compare that number with a reasonable expectation. Here's the code for the Spring Pet Clinic application, a popular sample Spring Framework application implemented in Java. First, I'll configure my project to use AppMap to record the behavior of the application when I run tests. AppMap works by recording the code execution paths of your app. A good way to create app maps is by recording unit, functional, or integration test cases. I'll be using unit tests. First, I define the packages of code I want to instrument in the appmap.yml configuration file. Then I add the AppMap plugin to the pom.xml file. The AppMap agent will record app maps when the tests are run. Now I'm ready to record an AppMap. Here I have a test for the vet repository that fetches all vet records from the database. When the test runs, AppMap creates a recording and stores it in the target/appmap directory. I open the AppMap, and in the left sidebar I can see the packages, classes, and functions that are exercised as part of the test, as well as the SQL queries. Looking at the trace view, I can see that the test is simple, yet it performs the database operations that allow me to identify the N+1 anti-pattern. I see about 6 queries in the AppMap. I can now run a detailed analysis of the results. AppMap recordings are stored in JSON format, so using a tool like JQ, I could run a query against the AppMap and get exact counts. Since our example is very simple, we can derive conclusions from the AppMap diagrams themselves. The SQL sequence shows the hallmark sign of the N+1 anti-pattern. A SQL select fetching all vet records, followed by a sequence of selects, each fetching the specialty details for one vet. That's 1 plus n total queries. That should be replaced with just one query containing a join. Now that we've identified that our data model indeed suffers from the N+1 anti-pattern, let's fix it and validate. The vet model reveals that a many-to-many relationship exists between the vet and the specialty entities. The easiest way to fix the N+1 issue without writing custom ORM queries is to define an entity graph for the vet repository that will instruct the Java Persistence API to fetch all specialty details with every vet record. Let's run the test again and compare the SQL commands in the trace. It worked. The sequence of 1 plus 6 selects has been replaced by one select with a join that fetches the vet records together with specialties in a single go. We are done with vets and can move on to the next data entity. This is how to find and eliminate the hard-to-detect N+1 anti-pattern with app maps in a few minutes. The application is now better prepared for a heavy production load. To give us feedback, visit us in Discord or find us on Twitter at Land of Apps, all one word. You can find full usage instructions and all these links on the AppMap page in the Visual Studio Code Marketplace. And you can find more information about Appland along with more videos at appland.com/videos. Thanks for watching.